Number 9, the 2024 AIME I Problem. Let A, B, C, D be points on the hyperbola x squared over 20 minus y squared over 24 equals 1, such that ABCD is a rhombus whose diagonals intersect at the origin. Find the greatest real number that is less than BD squared for all such rhombi. Okay, so ABCD is a rhombus on these hyperbolas. So let's say that point A is here, point B is here, point C is here, and point D is here. Now we're required to find the least possible value for BD squared, since it asks us for the greatest real number that is less than all of BD. Therefore, the line BD, which crosses the origin, should be as close as possible to the x-axis. Now for rhombuses, BD and AC forms a 90-degree angle, so AC should be as steep as possible. However, if AC is too steep like this, then it'll completely just miss the hyperbola. So we have to find the slanted asymptote for the hyperbola that is given, which is x squared over 20 minus y squared over 24 equals 1, to find the smallest value for BD squared. Now let's say that AC is y equals ax. If we plug it into the equation, the hyperbola here, x squared over 20 minus a squared x squared over 24 equals 1. Now multiply 120 on both sides, and we get 6x squared minus 5a squared x squared equals 120. If we factor it, 6 minus 5a squared times x squared equals 120. So x squared equals 6 minus 5a squared over 120. However, there should be a real number x that exists that satisfies this equation. So 6 minus 5a squared is not 0. Also, x squared is always equal or bigger than 0. So 6 minus 5a squared should be positive. Therefore, a squared or 5a squared is smaller than 6. So a squared is smaller than 6 over 5. Therefore, a is smaller than square root of 6 over 5 and bigger than square root of 6 over 5 minus square root of 6 over 5. Now let's just say that AC is y equals square root of 6 over 5 x. Then AC should be the asymptote. So it should not meet with a hyperbola. Then that is the smallest value that BD cannot reach. So it's kind of like the asymptote of the value of BD. So the slope of a line BD should be minus square root of 5 over 6. So BD should be y equals minus square root of 5 over 6x. Now we plug it into this x squared equals 6 minus 5a squared and 120 equation. And then we get 6 minus 5 times 5 over 6, 120 on top, which is equal to 120 over 6 minus 25 over 6, which is equal to 720 over 11. Therefore, x, or the x value for D is, B and D is plus or minus square root of 720 over 11. Now the y value, just put it into this equation, should be plus or minus square root of 600 over 11. Now let's just draw line BD. This point here is the origin, this is D, as in the picture above, and this is B. Now the length here is 2 times square root of 720 over 11. The length here is 2 times square root of 600 over 11. Therefore, the length of BD should be, by the Pythagorean theorem, the whole square root of 4 times 720 over 11 plus 600 over 11. Now, we have to find BD squared, so BD squared is equal to 4 times 1320 over 11. This is equal to 4 times 120, which is equal to 480. Therefore, BD squared is bigger than 480, since we set the slope of AC as something that we cannot reach. Therefore, the greatest number that is less than BD squared for all such rhombi is 480. So the answer is 480.